Hello. In this session, I'm going to work some homework problems from Chapter 2. And these problems may help you when you try to do the homework. So I'm going to start with the first problem that I encountered, which may not be the first problem that you will encounter, but the wording of this problem will be one of your problems. So in order to make CDs look more attractive, that's certificates of deposit from a bank, then they really are. Some banks advertise that their rates are higher than their competitors. But the fine print says, and on these kinds of contracts, you always want to look at the fine print, that the rate is simple interest rate, whereas maybe their competitors is compound interest. But anyway, if the person deposits $7,500, so that is a cash flow at time zero, at 7% per year, simple interest, what compound interest rate would yield the same amount of money in 3 years? So we're looking for an interest rate. We're looking for an amount of money that would be yielded at the future time, at 3 years, and we can calculate that from this simple interest. So first I'll draw the cash flow diagram. At time zero, you must make a $7,500 deposit. And then after 3 years, say 1, 2, 3 years, you'll get some future value, which we can calculate. That future value will be obtained at 7% interest for 3 years. So the formula for the interest that you will earn on this $7,500 is, recall I said the PIN formula, I equals PIN. This is the simple interest formula. That's the amount of interest that you'll earn during these 3 years. And the principal is $7,500. That's given. The rate is 0.77%. That's given. And the number of years is given as 3 years. This is per year. This is number of years. So this is going to be 21% of $7,500. If you do that multiplication, you will get $1,575. So that's how much interest is earned. So the future value will be the original principal that you started with, P, plus the interest that you earn. So for simple interest, F is equal to P plus I, which is $7,500 plus $1,575, which accumulates to $9,075. So this is how much the future value is. So now the question is, what's compound interest would give you that value? So the formula for the compound interest, this is the compound interest formula. For the future value is F is equal to P times 1 plus I to the n power, or you could use the symbolic formula. That is, well, we won't use this symbolic because we need to solve this thing for I, and you can't do that with the symbolic formula. So we know F is 9,075, P is 7,500, the unknown is I. We know n is 3. So we'll just plug into this equation. And this says 9,075 equals 7,500 times 1 plus I cubed. So in order to solve this for I, I'm going to take both sides of this. First I'll divide by 7,500 to get the 1 plus I isolated. And when I divide both sides by 7,500, I get 1.21 equals 1 plus I cubed. The next thing I'm going to do is take both of these sides of the equation to the 1/3 power, to the 0.3333 and so on. That's 1/3. And then do the same thing with this, 0.3333. Well, 1 plus I cubed to the 1/3 power is just 1 plus I. So on the right-hand side, I get 1 plus I. But on the left-hand side, I have to get the 1/3 root of 1.21. If you plug into a calculator, you will get that root is 1.0656. And if we subtract 1 from both sides of this equation, we get that I equals 0.0656, or 6.56%. So that's the answer. That's the compound interest rate over 3 years that's equivalent to a 7% simple interest rate. And that concludes problem 2.1 for me. The next problem that I accessed was problem 2.3 in the homework. That's chapter 2, number 3. Again, the number may not be the same for you. Levi Strauss has some of its jeans stonewashed under a contract with U.S. Garment Corp. If U.S. Garment Corp's operating cost per machine is $12,000 per year for years 1 and 2, and then increases by $1,000 per year through years 5, okay? What is the equivalent uniform annual cost per machine, years 1 through 5, at an interest rate of 7% per year? So A equals question mark. That's what we're looking for. We know I is 7% per year. And we're given a cash flow. Let's draw that cash flow up. That's $12,000 the first year. And it turns out it's $12,000 the second year. But then it starts going up by $1,000 a year. So the third year it'll be $13,000. And the fourth year it will be $14,000. And then going up 1,000 again, it'll be $15,000 in the fifth year. So we want to convert this series to a uniform series, an A series. We know how to convert a present value to an A series, and we know how to convert cash flows to a present value. So let's first get the present value and then find A given P, the annual equivalent to that present value. So that's what I'm going to do. My procedure is going to do is to find P, then get A from P using A equals P times A given P at rate I for n periods. And we know what I is 7 and n is 5. First I got to get P though. So what's the present value of that cash flow? Well, I'm going to make it easy on myself because I see a uniform series embedded in here. So if I just take and cut off everything right here at $12,000, I get a uniform series of $12,000 straight across. So I can take that and then account for this, and this, but I still haven't accounted for 1,000 here, 2,000 here, and 3,000 there. I'll do that later. So that will be equal to 12,000 P given A, 7% for 5 years. Then I'll get the present value of that $1,000. That would be 1,000 P given F, 7% for how many years? Well, it's at time 3, that $1,000 that's left over after I take the 12,000 away and deal with it here. So I will get that as 3 years. That goes back here 3 years. And then we have 2,000 left over here because we took the 12,000 out in this calculation. So we have 2,000 P given F, 7% for 4 years to get this back to here. And then finally we have 3,000 here. So it'll be 3,000 P given F, 7% for 5 years. If we compute this out, we will get P equals this number here. You can use your engineering economics career app, or you can use the tables, or you can use the formula, whatever you want. You will get $49,202 as the present worth of that uniform series across there of $12,000. Then we have this 1,000 that we have to bring back 3 years. And when we do, at 7%, its value is $816. And then we have 2,000 to bring back 4 years. That's this last piece up there. And that's $1,526. And then finally we have this 3,000 that's left over here. We want to bring that back 5 years at 7%, and that's $2,139. When you compute all that out, add it all up, you get $53,683. So that is the present worth of all of that. Now we know how to spread a present value over 5 years, so we have A is equal to P. Find A given P at rate I for n periods. We have the P value is 53,683. A given P, the rate is 7%, the number of years is 5, and we crank through that again using the career app or other means, and you get $13,093. That's the solution to this problem. The next problem in Chapter 2 that I accessed was this one. How many years will it take Raychem Inc. to accumulate $400,000? Whenever you hear it's written to accumulate, that means it's always looking for a future value. To accumulate $400,000 for a chemical feeder, if the company deposits $50,000 each year starting 1 year from now. So that sounds like a typical A series or uniform series if it's going to deposit the same amount and starting at the end of the first year or 1 year from now into an account that earns interest at 10% per year. So we're again, this is a little bit unusual problem. We're searching for n in the equation, and it says to round up your answer to the next integer value. So let's look at what we have. We want to accumulate to a future value of $400,000. So that's the future value, and we're going to deposit at the end of each year, say this is year 1, and this is year 2, and then so on up to some number of years. We're going to deposit $50,000. Well, that's a little bit large for $50,000 compared to that $400,000. So $50,000, and then another $50,000. And we're going to keep doing those $50,000 each year until the last year. And in the last year, we also will, of course, put that $50,000, and hopefully that will kick us over that $400,000, and that'll be the end value. So the equation that we're going to have is the future value, which is known, is equal to the uniform series amount, A, F given A at rate I for n periods. Okay, well, we know the future value, that's $400,000. And we know how much each payment in the uniform series is, and that's $50,000. We know the interest rate is 10% per year, so we'll say F given A, 10%. What is the unknown is n. What makes this equation actually not exactly equal, but at least makes the right-hand side just greater than the left-hand side. That means we've accumulated at least $400,000. We're going to have to solve this one by trial and error because that's kind of a complicated formula to solve for n. So I'm going to open my app, my Engineering Economics Career app, and I've got it open here, and I'm going to go back because this is the formula that I want. So I'm going to go to F given A, and I have an interest rate of 10%, which I've already put in, and I have a number of periods. I guessed, I'm going to start by guessing 5 years. So I'm going to say try n equals 5. When you make 5 years of payments, these are going to grow. They're going to get bigger and bigger. So as we go forward to some number of years, just trying 5, they may add up to 400,000. We'll see. Okay. So let's look at just the right-hand side when n equals 5. And I'm going to put in 5 for my n, 10% for my interest rate, and $50,000 for my A value, and I'm going to say calculate. And then I get the right-hand side is $305,255. So that's a little bit low. Now, when we go to n equals 6, we'll try that, but I don't think it's going to get us there because that's just going to add another 50,000 out here, so to speak. So I'm going to do it though and see how close we get. Try n equals 6, and we'll see what we get. So in my Engineering Economics Career app, we still have all the data in. We're still looking for the same thing. All I have to do is change the n value from 5 to 6 and then tell it to recalculate the future value. Well, when it does that, it gets $385,780.50, so I'll put 781. Now, we're very close to that 400,000. We know when we add a a seventh year here, it's going to kick us over 400,000, right? Because we are very close, and 50,000, just the 50,000 itself will kick us over. So the answer is the next highest integer that gets me over 400,000 is n equals 7. So that's the answer to this question, and we'll move on to the next one. The next problem in Chapter 2 homework that I'm going to go over with you says, Omega Instruments budgeted $330,000 per year to pay for special order ceramic parts for the next 5 years. So that's $330,000. That's a uniform series for 5 years. That's what they budgeted anyway. A equals $330,000 per year, and n equals 5. Okay. If the company expects the cost of the parts to increase uniformly, according to an arithmetic gradient, so that's a G series now, of $10,000 a year, so they expect the price of the parts to go up by $10,000 per year. That's a G, capital G. And the interest rate is 8%. And they're asking, what is the estimated cost in the first year at an annual rate of 8%? Well, if they budgeted $330,000 a year, they must have known they needed to budget enough to cover the cost, even though the costs were increasing. So let me put the budgeted cash flow here. That's $330,000 a year for the 5 years. This is the budgeted cash flow. Straight across at $330,000. Now the actual cash flow is going to be a little bit different. It's going to be increasing by $10,000 a year, but certainly the actual cash flow is not going to start at 0. So we're going to have some amount of cash flow, I'll say A, then that same amount again the next year, but only the next year it'll be plus 10,000. So this will be A plus 10,000, and then the next year it'll be A plus 20,000, and so on, A plus 30,000. And then finally, this will be A plus 40,000. And this is actually the value of this A is what I'm searching for. So that A is the question mark. Well, remember when we had a series like this, it's called a combined series. It's basically a uniform series plus a gradient series, an arithmetic gradient series. So we have the uniform series. If we partition this series into 2 parts, a uniform series of A amount, and then a gradient series, which starts at 0, 10,000, 20,000. This uniform series here is A, and that's the unknown. And then 30,000, and finally 40,000. So what we're going to do is we're going to set the annual equivalent of these 2 series equal to $330,000, which is what they budgeted, and solve that equation for the unknown value, which is A, which is the amount of the cash flow in the first period. So let me set that equation up. I'm going to say basically A budgeted equals the amount, and it's not a uniform series, it's a gradient series, A plus basically G spent. So A budget is $330,000, and this is the A that's the unknown. That's the first payment, the first year. And then we have a gradient here of 10,000, and we can convert that to a uniform series. This is a uniform series, this is a uniform, this has to be a uniform series. A given G, 8% for 5 periods. So this is one equation, one unknown. We just need to solve it for A. A equals, let me bring this to the other side. It'll be 330,000. And then when I bring it over, I have to subtract it, 10,000. A given G, 8% for 5 periods. So now we just need to solve this, and then we have our result. So this will be 330,000, and I'll use my Engineering Economics Career app to get this on my cell phone. So I go to the Engineering Economics Career app, and I want the uniform series equivalent of a gradient series, and that's this slot. The rate is 8%. I've already put that in. The year is 5. I put that in already. And finally, the gradient amount is 10,000, which I've also put in. So I say calculate, and I get 18,464.71, which I'll make 65. So now I have my value of A, and that turns out to be, if you calculate, do the subtraction, 311,535. So if you have a series that starts at 311,000 and 535, and it increases by 10,000 each year, it'll be equivalent to a series of 330,000 a year for 5 years. They would have the same future value, these two series. They would have the same present value, therefore they are equivalent. And that solves this problem. This problem was difficult to interpret at first, to really understand what the questioner was asking for. And so I'm working this for you, so because I thought it would be difficult. Thank you. The last question I'm going to work for you in this little session is one of the end of the chapter problems, and it's problem 22 at the end of the chapter in your ebook. And it says, if GHD Plastics purchases a new building now for, so you know that's going to be a present value, P equals to $1.3 million, and what must the building be worth 10 years from now? So N equals 10 years. If the company expects all expenditures to earn a rate of return of 18% per year, so that's RI, 18% per year. So what must the building be worth in 10 years? They're looking for F, right? Okay, that's the future. So you have basically a very simple cash flow. You have $1.3 million expensed now, and then you want to know what the future value must be at n equals 10 if the rate is 18% per year. This is years. Always keep track of your units. So this is a pretty straightforward example of an f given p. F is equal to p times f given p rate I for n periods. You can use your engineering economics career app for that, or you can actually, that's a very simple formula. It's 1 plus I to the n, right? So you could say 1.3 million times 1.18 to the 10th power, or you can go about it from your engineering economics career app. 1.3 million written out here, f given p, 18%, 10 years, and that's equal to something. Okay, I'll get the engineering economics career app up here. Go back here, and I want f given p. That's the that's the very top one. F given p. The interest rate is 18%. That's a rate that they wish to return. I touched the wrong number there. 1.8, and oh, I did the wrong cell. That's 1.8. Boy, I'm having a hard time here. Okay, 18%. The number of periods is 10. And the present value is 1.3. One, 3, 0, 0, 0, 0, 0. I think I got the right number of zeros there. No, I think I need one more. And then we'll calculate. And holy smokes, that's a lot of money. Looks like 6.8 million. 6803. 803,982. Okay, let's do this calculation just to be sure. So I'm going to go back to the calculator. I have the calculator on my cell phone as well, and I'm going to go to 1.18 and raise that to the 10th power. That's 5.23, etc. So 1.18 to the 10th power is 5. It's going to be 5 times this number. So I'll multiply this times 1,300,000. Whoops, I missed a 1. I didn't have the other one in there. 1.18. No, clear. 1.18 to the 10th power is 5.3 multiply times, hope I can get this in there just correctly, 1, 3, 0, 0, 0, 0, 0 equals, yep, 6.83986. Well, it's close. The app gave me 982. This gave me 986. And either way, the answer key is if you're within 2%. So that would be certainly easy. This number here comes out to be 680 6803986. And that concludes our problem session.